Hello. Okay. What is the Spark? Spark is a distributed compute engine which distributed our data to process it. Suppose we have one computer, it has a limitation RAM, ROM, CPU. Um, in the Spark, we have multiple computers. Let's consider 10 computers. It's called the cluster of computers. In this cluster, we don't have a limit because of in the cluster we distribute data into small parts. Spark architecture. This is the driver program, cluster manager, worker node, and in worker node executor cache. Cluster manager. It's a manage the cluster. This manager create a driver node. We have a send code in it come into driver node. Driver work on this data doing transformation tasks and give to cluster manager. Then driver to decide the worker node. Then task divide into worker node. It's worker node on the data. Lazy evaluation. Let's consider we have a data frame. We want to perform transformation like we are just selecting. It's create a logical plan. Consider what transformation 1, transformation 2, transformation 3. According to the optimization, and when we trigger the action, it will execute the logical plan. Look at this is task, transformation 1, 2, 3, logical plan. Whenever we hit action button, the lazy evaluation execute. This is a job, stages, task 1, task 2. The job has task. Job has different stages. Okay, one job. There are the different stages. There are three stages divide and styles have a multiple tasks. One job have three stages. Sometimes it's more than three. Okay, because they have multiple tasks. Spark component API. It's allow Python language SQL, low-level API, RDD, and distributed variables. Structured API, data frame, dataset, and SQL. Libraries and ecosystem, structure streaming, and advanced analysis. Driver, driver heart of the Spark. M- uh, this manage information and state of executor. Analysis, distribution, and schedule the work on executors. Executor executor the node execute the node. Report the status of execution to driver. A user assign a job to driver and driver into turn analysis distribution and breaks down the job to drivers into stages and tasks, and it's assigned it's to executor. Here is executor as basically is a JVM process which runs on the cluster of machine. It consists of cores. Note, each task can only work with one partition of data at, at a time. Task can execute in parallel. Executor are JVM process running on cluster machines. Executor host core, and each core can run one task at a time. What is a partitioning? Partitioning to allow every executor to work parallel. Spark breakdowns the data into chunks called partition. For example, the bag of marbles contained bunch of marbles, which can be considered as a partition. What is a transformation? The instruction or code to modify and transform data is known as transformation. Example, select, where, group by, etc. Transformation help is building the logical plan. Two type of transformation: narrow transformation and wide transformation. Narrow transformation, after the applying transformation, each partition contributes at most one partition, like map, filter. In a wide transformation, after applying transformation, one partition contribute to more than one partition. This is type of transformation lead to data shuffle. Okay, what is what are actions? To trigger the execution, we need to call an action. This is the basically execute the plan, create transformation. Actions are three types: view data in console, collect data to native language, write data to output source. Sparks prefer lazy evaluation. Spark will wait last moment to execute the graph of computation. This is allows Spark to optimize plan and use the resources properly for execution. What is a Spark session? The driver process is known as a Spark session. It's a entry point for Spark execution. The Spark session execute the code in cluster, and the relation is 1 to 1. Structure API data frame. Data frame is a most common structure API, represent like table. The table is represent in form of rows and columns. A data frame has schema, which is the metadata for columns. Data in data frame are partition. Data frames are immutable. How Spark work on data partitioning? Logical plan and physical plan. So totally okay. This is the logical plan. It is the first um and resolve logic, then catalog, then plan, and then move to catalyst one. It's optimize and optimize the logical plan and DAG. This is the logical plan. Physical plan means optimize logical plan. Physical, physical code mode one based physical plan, and cluster for execution is physical plan. DAG means direct acyclic graph. Directed acyclic graph. A DAG represent the logical execution plan of Spark job. Spark session from PySpark.sql input session Spark equals to in round bracket Spark session dot builder dot app name in round bracket Spark introduction, then dot master local square bracket star get or create. Monolithic and distributed. Monolithic scaling, expensive, low availability. Means it's a work like this 1, 2, 3, 4, 5. In distributed, horizontal scaling, economical and high availability. Suppose we have a 1, 2, 3. This is not executed over like 1, 2, 3. It's all executed like 1, 2, 3. इधर भी जा रहा है, इधर भी जा रहा है, इधर भी जा रहा है, इधर भी जा रहा है. लेकिन यहाँ पे एक बार स्टेप बाय स्टेप हो. What is the repartitioning in Spark? Repartitioning basically when a Spark reshuffle data to create a new number of partition. It's actually move data around across the cluster, which can be a bit heavy on performance, but it's useful when we want to increase partition or um, balance our data. Like before doing joins or group by. For example, df.partition 5 Spark will redistribute the data into 5 partition evenly. Like we have a 40, 40, 40, 40. And this is the repartition. It means 160 MB data. Okay. This is divided into 40, 40, 40 MB. It's a depend on a different use cases. It's we need to increase partition for better parallelism, like before a heavy joins group by or shuffle heavy transformation, then we'll go to repartition. Because of it, evenly redistribute data across the partition. But if we join one to reduce number of partition, okay, repartition and coalesce. In the repartition increase or decrease number of partition. In coalesce, decrease the number of partition only. Uh, in repartition, full shuffle of the data across the all node. In coalesce, minimize shuffle, avoid full shuffle. In repartition, when increase partition or evenly redistribution data. But in coalesce, when the reducing number of partition for optimization output. Um, in repartition, right? Ex expensive due to full shuffle, but in coalesce, inexpensive due to limited movement. In repartition, before writing information like join, group by, but in coalesce, before writing data into disk. In repartition, evenly redistribute across the partition. Narrow is used in coalesce. Narrow existing partition merge add once. Join strategy in Spark. Short merge join. Default join implementations since Spark 2.3 step. Sort both the dataset by using a join key. Merge step by step. Result. This is data frame 1 and this is data frame 2 customer. Okay. Both table. Sort both data set by using join key. Okay. And there is common in customer ID. This and this. Result. Customer ID. Okay. These are the steps. Shuffle hash join. Default join implementation steps partition, shuffling, hashing, and in-memory join. Result aggregation. Partition like data frame 1 order and do partition basis on the customer ID. Okay, customer ID 1 1. This one 50 and 76. This partition 1 and like we have find 2 102 basis on customer ID we do the partition. Okay, yeah, and Second data frame is customer. We also do the partition same like using customer ID. Yes, this is John. 102 is Emma. 103 is Michael. Hashing. A smaller data set will get convert to hash table like node 1, node 2, node 3. And joining node 1, customer ID, node 2, node 3. The result is node 1, 1, 3, 1, 0. This is amount of John. Okay, node 2, node 3. And then result will be in a paper format. Broadcast hash join. Why do you need to broadcast hash join? When the joining two datasets, Spark normally shuffle the data across the cluster to align keys. This is execute and slow, especially with the big data. But when the dataset is small enough to fit into memory, we can broadcast it to all worker nodes, avoid shuffle. The large dataset perform fast local joins on each node. How does broadcast join work? Step 1, identify small table. Spark def- uh, defects that one df is small and other is large. Uh, it's broadcast this small table and worker nodes. It's a fully copy goes to each node. This is the data frame 1. This is a big table. Data frame 2 is customer. Step 2, broadcast small table. The large data frame is already partitioned across the nodes. Since every node now have a copy of small table, each node can do the join locally on its partition of big data, like the driver, this is worker node 2, worker node 3. How to read CSV file? df equals to spark.read.csv in a round bracket, file path, CSV file path. Then header is true, infer schema is true, and df.show. Header equals to true. First row columns name म्हणजे कॉलम मधला जी पहिली रो आहे म्हणजे टेबलचं नाव जसं काही कस्टमर आय डी नेम ॲड्रेस हे कॉलम नेम मधून घेतो पहिली रो सगळ्यात पहिली रो ठीक आहे इन्फर स्कीमा इज ट्रू स्पार्क ऑटोमॅटिकली डिटेक्ट द डेटा टाइप ऑफ इनकमिंग ओके डेटा आता स्पार्क दो डेटा टाइप घेतो जसं की कस्टमर आय डी कस्टमर आय डी हा इंटिजर असावा ठीक आहे कस्टमर नेम स्ट्रिंग असावं सॅलरी हे डेसिमल मध्ये असावी ओके आणि जर समजा आपण इन्फर स्कीमा नाही घेतला ट्रू नाही घेतला तर तो बाय डिफॉल्ट स्ट्रिंग घेईल हाऊ टू क्रिएट अ स्कीमा स्ट्रक फिल especially manual schema struct field and struct type struct which is define our structure of data frame list of struct field ओके उदाहरण बघा struct type which define our structure of data frame list of struct field ओके आयडी आहे वन नेम आहे हा एका व्यक्तीचा रेकॉर्ड आहे आपण यात अजून काही आयडी आणि एज ऍड केलं तर डेटा फ्रेम तयार होते ठीक आहे स्ट्रक फील्ड कोणता डेटा टाइप वापरला आहे लाईक आयडी ही इंट पाहिजे नेम स्ट्रिंग पाहिजे आणि हे इंट फाईल INT पाहिजे. ठीक आहे. मग स्कीमा टाइप हे बघा इथं स्ट्रक फील्ड तयार केलेली आहे. म्हणजे स्ट्रक फील्ड ओके. स्टेटमेंट दिस इज डेटा फील्ड आणि त्याच्यातला डेटा कोणत्या टाइपमध्ये असणार तर स्ट्रक फील्ड डिसाईड करणार. ठीक आहे. म्हणजे स्ट्रक फील्ड आपल्याला डिसाईड करायला लागेल. अनदर टाइप इज df.myschema id is integer, name is string, age is integer. ओके. सिनॅरिओ आता हे बघा इथं आयडी नेम एज हा डेटा आहे. जो आपण रीड करायला शिकलो. पर स्कीमा ऑफ मोड इज परमिसिव्ह df डॉट वरील CSV फाईल दिलेल्या असतील तर 3 ते 4च्या ॲड्रेसमध्ये इंडिया तर आपण 5 नल हायलाइट केलेला आहे. ठीक आहे. Why its header is true? It's a tell Spark that the first row of CSV file contains column name. हेडर ट्रू का ठेवायचा? कारण स्पार्कला सांगितलं जाणार की जी पहिली रो आहे ते कॉलमचे नाव आहे. ठीक आहे. हे बघा आयडी, नेम, एज, सॅलरी, ॲड्रेस अँड नॉमिनी. इफ हेडर इज फॉल्स डिफॉल्ट आउटपुट काय येईल? एक्झिक्युशन कॉलम 1, कॉलम 2 असे येईल. So we use header true to get proper column name. In first true. Spark automatically detect the data type columns like ID, integer, string, name, and salary integer. Okay. If infer schema is false, output like ID string, name also string, age also string, and salary also string. In the production, header is true use, but in infer schema, false often avoid because of the scan data and can slow the performance. Why? Because in production मध्ये हेडर ट्रू ठेवतात कारण आपल्याला कॉलमचे नाव दिसले पाहिजे प्रॉपर. इनपर स्कीमा फॉल्स ठेवतात कारण एंटायर डेटा स्कॅन केला जातो त्यामुळे मग प्रत्येक हे हेवी ऑपरेशन होणार आणि कॉस्ट वाढेल. बिकॉज ऑफ कॉस्ट. Mode. Importance of corrupted data. Permissive means default mode. It's a row is corrupted. Spark does not fail. Spark file incorrect. Columns with null. Column fill okay. And record still appear in output. Use cases when a data many content few of bad records. मोस्ट कॉमनली यूज इन प्रोडक्शन पाईपलाईन. डेटा जसा आहे तसाच दाखवणार. जसे मागील टेबलमध्ये आहे 3 व 4चा पत्ता इंडिया आले आहे, पण 5 मध्ये पत्ताच नाही. तरी स्पार्क टेबल पूर्ण टेबल दाखवेल. स्पार्क हे पूर्ण टेबल दाखवत. ओके. ड्रॉप ऑल फॉरवर्ड. If row is corrupted, Spark drop that row. Then record will be not appear in output. Which cases when corrupted records are not proper. You want only clean data. Fail fast if Spark finds any corrupted record. Spark immediately error and stop the job. Which cases when a data quality must be perfect, common in financial or critical pipeline. If transformation, narrow transformation, each partition of uh, parent RDD data frame is used only one partition of child. In a narrow transformation, no data shuffle between nodes like map, filter, flat map, select with columns, union. It's faster for execution. Like a df equals to df dot filter. Filter df age is greater than 25. In wide transformation, child partition depends on the multiple parent partition. Data shuffle happen across the node. Okay, group by, reduce by, join, distinct, order by. and DF group by department count. It's slow execution. Action is a operation that's trigger execution of transformation and result to driver or write data to stage storage. Spark use lazy evaluation. Transformation runs only when a action is called. Show, collect, count, first, take token, right, and for example, df.show. DAG. DAG means direct acyclic graph. Spark create a DAG of transformation and execute it only when an action is called. Like this is okay. DAG flow. First, this is the code. First is file path. Then read the CSV file. Then filter edge. Filter edge in narrow transformation. Div.select name and salary. And select name and salary is narrow transformation. And we group by the group by using a name, which is wide transformation. And in the show, it's action. In the DAG, the logical execution plan of transformation will be executed before a action is triggered is job. What is the catalyst optimizer? Catalyst optimizer is the query engine in PySpark. It's automatically optimize the query to improve performance. Like okay, df.filter in bracket is greater than 25. Select name df.shoot. What exactly Catalyst does? Remove unnecessary columns, push filter early, create a optimized execution plan. Okay. Catalyst optimizer step. Firstly, analyze. Check tables, column names, validate the schema. Then two logical plan. Create a logical plan for click first filter is greater than age greater than 25. Select name and salary. Third is optimization. Applied optimization rule like a predicate push down, column column pruning, physical plan, choose best execution strategy like a hash aggregation, broadcast join. It's totally um, done in Catalyst Optimizer. So Catalyst Optimizer is a query engine in Spark. It's automatically optimize the query, improve the performance. हे सगळं स्टेप घेणार तो. ठीक आहे. Real example of optimization. Query dev.select names will optimize the catalyst. Filter filter push early, better performance. आता okay. Difference between RDD data frame and dataset. RDD is resilient distribution dataset are only core data structure in Spark, offering low level transformation and action. In a data frame, provide a higher level API on the top of RDD, allowing SQL-like operation with the schema information, making more optimized in a data frame. Datasets available in Scala and Java is combine of benefit of RDD and data frame, offering type safety and compile time checks while optimizing with the Catalyst optimizer. Spark context and Spark role. Okay, Spark context and Spark session and their role. Spark context is a use entry point for Spark application managing the connection of the cluster. It was necessary in early Spark version. Spark session is introducing into Spark 2.0. It is the entry point that's include both Spark contents and SQL contents. It's a simplifier working with structured data. It's and allowed to create data frame directly. Explanation group by window function in Spark. Group by aggregated data by groups, while a Windows function calculate value over the windows of rows used for rolling calculation. Okay. Group by and window function. Group by is aggregated data by groups, while the window function calculates value over an window of rows, useful for rolling calculation. Okay. What are the what UDF and when will you use them? UDF is user defined function. Let's us apply the custom Python function to data frame. Columns used for complex transformation, not supported by Spark function. Okay. Optimization of PySpark use broadcast variable. When joining smaller data frame with large ones, consider using a broadcast variable. This techniques helps to distributing small data frame to all worker nodes, reducing data shuffling during the join operation. Partition. Ensure that your data frame are properly partitioning to optimize data distribute across the worker nodes. Choose appropriate partitioning columns to minimize the data shuffling during the transformation. And third is intermediate result. If you have multiple operation on a same data frame, consider persistent the intermediate in memory or disk. This is to prevent recomputation and improve performance. Use data frame API instead of RDD. The data frame API in Spark is optimized by the performance better than RDD. Whenever possible, prefer to use data frame for transformation and action. Avoid user-defined function. When not necessary, user-defined function in Spark can be less performance than built-in function. If there is an interval built-in function, it's use the UDF. Increase the parallelism. Adjust the level of parallelism by a configuration of number of partition in the transformation like repartition and coalesce. This enhance the execution of task. Minimize the data shuffling. Data shuffling in expensive operation. Minimize unnecessary shuffling by um, carefully choose joins key, optimize your data. Yeah, and optimize serialized format. Choose the appropriate serialization format based on your data processing needs. Consider you move efficient serialization format like a Parquet. How to cache and persist work in PySpark. Cache and persist are techniques to store intermediate result in memory, making uh, repeated access faster. Cache defaults to memory storage, while the re, repartition, while the persist, it allows specifically storage levels like a memory only or a memory disk. They helps to iterate process, reducing recomputation. Cache and persisting are taking stored intermediate result in memory and making repeated access folder like cache. Cache default the memory storage, and persist is allowed to specify storage levels like a memory only or disk only. They help intermediate process, reducing the recomputation. Okay, and how to reduce the data shuffling? To reduce data shuffling, I try to avoid white transformation like group by. Use the repartition carefully. Leverages be like broadcast joins for small table and catch a result when the beneficial minimize shuffle improve job and performance. Handle skewed data. For skew data, I use a technique like sorting and distributed skew keys, repartitioning, or leveraging custom partition, sometimes using broadcast join or increase the parallelism. It's a help to balance the processing. How to handle schema validation? In PySpark validate schema when creating data frame of uh, data frame if data type doesn't match with the schema. PySpark rise the error, ensuring the data consistent schema inference of automatic with the action with option to enforce schema of for structured data. Strict schema for structured data. What is the adaptive query execution? Adaptive query execution adjusts the query plan during the runtime, optimizing for data characteristic. It can be optimized joins, repartitioning data, and balance workload, improve query performance, especially for skew data. How would you implement SCD type in PySpark? SCD type can be implemented by comparing of incoming records with the current state. For ACD type 2, we add a new row with effectively dates, making a previous one as a inactive. Okay, how would you implement data quality checks? Apply checks for nulls, unique values, data types, validation, and column constraint. Also set up alerts or logs logs if quality issue are detected. Okay. ही 0 to hero स्पार्क त्याच्यातलं डबल घेतलं जाईल काहीही थोडस ओके स्पार्क 0 to hero हे बघा त्याचं स्पार्क कंपोनंट सांगितलं स्पार्क इज अ ओपन सोर्स युनिफाईड कम्प्युट इंजिन इट सेट्स अ लायब्ररी फॉर parallel data processing computer cluster. It supports Scala, Python, Java, R. Spark component like low-level API is RDD, is distributed variable, structured API, data frames, dataset and SQL, libraries and ecosystem, structure and streaming, advanced analysis. Okay, how does Spark work? What are the drivers and executors? What is the job stages and tasks? Jobs, stages and these tasks. Driver is heart of Spark application. It's a manage the information and state of executor, analyze, distribute, and schedule the work on executor. Executor is execute the code, report state execution to driver. A user assign a job to driver. Okay, then the driver uh, turn analysis distribution to break down the job into stages and tasks and it assigned to executor. Here is a basically JVM process which run in cluster machine. It's consist of course note each task can only one Each task can only work on one partition on the date at a time. Tasks can execute in parallel. Executor for JVM processing running or cluster machine, and execute host core, and each core can run one task at the time. What is a partitioning? To allow every executor to work in parallel. Spark breakdown into chunks called partition. So, from the last example, the bag of content a bunch of marble, which can be considered as a partition. What is a transformation? Like, yeah, in instruction or code to modify a transformation data known as transformation, like select, via, group by, etc. Transformation help to his building logical plan. Narrow transformation and wide transformation. After after the applied transformation, each partition mm, each partition contributes at the most one partition. In wide transformation, after apply the transformation, if one partition contribute to more than one partition, this type of transformation lead to data shuffle. What is the action? Action is to trigger the execution. We need a call action. Is basically execute the plan by transformation. Action are three types: view data in console, collect data in native language, write data, output data source. Spark prefer lazy evaluation. Spark will wait last moment to execute the graph computation. This is allows Spark to optimize plan and use resources properly for execution. What is the Spark session? The driver process in a known and Spark session. It is the entry point of Spark execution. The Spark session instant of executed the code in the cluster and re and the relation one in one. For example, one Spark application we will have one Spark session instance structured API. Data frame are most common structured API. It's like a represent table. The table represent row and columns. Data frame have a schema which have metadata columns. Data frame data in data frame are partitioning. Data frame are immutable. How Spark work on data partition? Spark distribute the data in form of partition, like a logical plan and physical plan. This are the logical plan. First is phase execution plan, like that. Okay, this is the Spark session. Like Spark session in memory, Spark contains okay, employee ID. This is the correct data frame is employee added number of partition. Okay, this is wait. If you want to change this Spark session object name, this code USB example. Okay. For finds on data frame, rows, columns, structure, select. Okay, this is the example. Okay, we want to find the schema. This is the schema. Okay, like the employed string type true, string type string text struct field. Okay, look at this, the struct type struct field. Okay, name and divide the data frame divided into two parts, row and columns. You need to data frame to manipulate this column. This is on salary. Okay, I think this is all about code. Heading column, okay, renaming column. This is the totally. हम्म, वही देखते कुछ थ्योरी मिलता है क्या इसमें? ओके, त्याच्यात सगळं theoretical आहे. In and on data frame sorting. इनफॅक्ट विंडो फंक्शन राहिलं वाटतं. Union, okay. Union versus union all. Union remove the duplicates from the combination data sets where union all doesn't. Okay. Window function. Okay. Partition केलाय सगळं आहे. Okay. Hmm. आता पायथन नाही, PySpark. क्लासिकल आहे. ठीक आहे. आपण ChatGPT ला विचारू. विंडो फंक्शन घेऊ आपण आता. ठीक आहे. पण ChatGPT लाच विचार. ठीक आहे. ओके. क्लोज साइड बार. Okay. Window function in PySpark. A window function performs calculation across the group of row window without the collapsing like group by. It skip original one rows, add a new column. Okay. This is the syntax. You can see. Type of window function. Row number is the ranking. Uh, Rank, dense rank, aggregation function like sum, average, mean, max, and analytical function lead and lag. This is the example of data sets. Okay, row number. Mhm. Assign row number as per the ID. Okay, this is the output. 1, 2, 3, 1, 1, 2. Y. Okay, rank versus dense rank. Rank is keep the number 1, 1, 3. Okay, in dense rank there is no gap. 1, 1, and then 2. Running total cumulative, running total output. Okay, lag function and Lag is previous row is next row. Partition by like group by. This does not reduce the row order by. It's a define row sequence inside the partition. Basically, okay. A window function operate one partition keeps row always over partition. Most ask row number, rank, dense, and lead and black. Yes, a real time basic thing. Great. First, must have question. Row number, unique number, there is no duplicate. Okay. Row number one, two, three. In rank, same rank with gaps. One. Okay, because you have value when 1200, it's also one. Okay, because both are same. And then it skip 100 is 3 value 100 is 3. But then it's rank. Look at this. One, both are one. Okay, then there is two. This is the dense rank. Okay. Yeah. This is the end of Spice Park. Okay. And then find out the optimization techniques of Spice Park. Okay. Optimization techniques why needed? Because it's a Pascal distribution system to work out slow jobs and firstly reduce the shuffle, most important. Shuffle is data movement across the road is very expensive. Avoid unnecessary group by multiple joins by transformation. Use the repartition wisely, broadcast join. Use a proper partitioning, control parallelism. Uh, Repartition increase the number of partition shuffle. Call is reduce the partition is no shuffle. Like it's help to join and window function. Look at this. This is the repartition based on ID. Broadcast join to big optimization. When the stubble is small, okay, avoid shuffle and faster join. Look at the div dot join in broadcast div2. Okay, basis on ID. This is the okay. This is the broadcast join. Cache and persist store intermediate data into memory, like div.cache. Are used for multiple times in iterative operation. Column pruning. Select only required column like div.select, select name, and do not select or overall select data like star. Filter early predicate push down. Like this div dot filter, we want to find greater than 30. It's best practice for Parquet and ORC. Okay, use the efficient file format. CSV is slow, JSON is slow, Parquet and ORC is faster. Columnar storage. This is the columnar storage. Okay, avoid user-defined function. Python is user-defined function. Is there is no optimization. Use a built-in function like a spark.sql function. Optimize joins like broadcast joins on small table, sort merge join for last table, and join one partition column. Avoid skew. Handle data skew when one key has too much data. Solution like sorting techniques, repartition, skew joins, handling. Use a window function carefully. Optimize partition properly. Limited row between. Okay, avoid by transformation. Map uh, in map in a transformation map filter wide group by wide equals to shuffle. Okay, wide is okay slow. Avoid transformation because there is a group by and it's expensive join. User explanation is very important. Explanation like a physical plan, shuffle event types, and adaptive query execution. Dynamically partition SKU data handling like a Spark configuration dot set and Spark adaptive solution is to enable us to okay. Dynamically partition pruning. It's a read only require partition dev dot filter like we want to find some specific year data, then do the partition and pruning. Okay. Optimization PySpark reduce the shuffle, minimize data, and using built-in distributing feature efficiently. Yeah, this is the end of this data. Thank you so much.